Okay, so now we're going to cover incenters. So for incenters, we have the angle bisectors of the angles of a triangle intersect at a point called the incenter. So in our blanks here, we're going to put angle bisectors. Okay, so if we look at this, we have the angle bisectors of the angles of the triangle. These are the angles of the triangle, are intersecting at this incenter. So P is my incenter, and here I see that these lines are angle bisectors on the three vertices of the triangle. The incenter is always equidistant from the sides of the triangle. So once I recognize that I've got this angle bisector, now what we're saying is that the incenter is always equidistant from the sides. These are the sides. So what you're going to mark here are these right here. Okay? And so this actually, what we want to highlight and remember as our key terms for this then is going to be that incenter uses angle bisectors, and the key is going to be our sides. Alright, so we're going to use the diagram to the left to answer the following questions. So first of all, list the angle bisectors. Well, our angle bisectors are coming right out from our angle and they're going to our incenter. So I have AP and BP and CP. The incenter is P. And then we want to list our congruent segments. So I'm going to start with these segments that are going out to the sides that are congruent. So we have DP, which is congruent to EP, which is congruent to FP. I wanted to make a little connection here. You don't have to get these notes out, but remember when we talked about the angle bisector theorem, we have an angle bisector, and we've got our perpendicular lines, and we know that then these are congruent, and our angles are congruent. And if we look at that, that's the same thing we have here on these incenters, where if I just look at one of these right here, I have my angle bisector. I've got my two lines coming out. These are congruent, and those are perpendicular. So I wanted to make that connection for you to the angle bisector theorem. And then we have some other things that are congruent, and we're going to kind of reach back and remember our hypotenuse-leg theorem from our proofs. So if I have this triangle right here, and I also have this triangle right here, I've got two right triangles. I'm going to put this over here just so you're looking at it like that. The hypotenuse-leg theorem said that if I have two triangles and their hypotenuse and their legs are congruent, then the triangles are all congruent. Well, here, these two triangles are sharing this side. So that would mean if I use the reflexive property here, I could say that this hypotenuse and leg of this triangle are congruent to the hypotenuse and leg of this triangle, which then would mean that both of these triangles are congruent. And then if I use the corresponding parts of congruent triangles, the CP, CTC, what that means is that this side right here is congruent to that side right there. So for our congruency markings, to add to this, we can also say that AD is congruent to AF. Okay, and then what we can do is look at each of these sets of triangles here and do the same thing. Hypotenuse leg, so that would mean that this side is congruent to that side. So that is going to be FC is congruent to EC. And then if I look at one more triangle up here, I've got my hypotenuse, they are congruent because of reflexive property, and a leg here, which would mean that those two segments are congruent. So I've got DB is congruent to EB. So those are our congruence markings. There's a lot on this Incenter, so you're going to have to remember all these things when we're working the problems, but if you remember how you got to these congruency markings, it'll help you, and we're going to focus on in-center, angle bisectors, and a key is that our sides, going out in-center to the sides, are what are congruent. We're going to look at number 1 and do that together. So I have the key word here, in-center. So I'm going to be thinking these are angle bisectors, and the key is that the sides are going to be equidistant from the in-center. So that means that this right here is going to be congruent to this right here, in-center to side, and in-center to side. Okay, remember, we're not going out to the vertices on this. That's not what we're going to focus on first. We're going to the sides. So if this is 8, then that means that would be 8, and that would be 8 as well. So for NP, my first answer there is going to be 8. All right, so next I'm going to just look at the diagram, and I want to figure out, remember these are all right angles. So I'm going to look at and see if I have a right triangle where I have 2 sides and I'm just missing one side, so that I can get some more numbers on here. So I have, if I look at this triangle right here, my hypotenuse is x. This is what I'm going to be solving for. I have 8 squared plus 17 squared is equal to x squared. So that's 64 plus 289 is equal to x squared. Combine that, that's 353 is equal to x squared. And so that tells me that I take the square root of both sides. I'm just going to flip it here. X is equal to 18.8. So I'm going to come over here to PK and put 18.8 because that's the hypotenuse of that small right triangle there. Okay, then I have NK. So if I look over here at NK, remember the scenario here is I have the 2 right triangles, and they share the hypotenuse, and their legs are both 8, so that means if this is 17, then this over here is also going to be 17. So I'm going to put 17 for NK. And then the last one I have to figure out is LO. So I'm going to use X for this as well. And here I have a right triangle. This is my right angle, so 13 is my hypotenuse. So this is a leg and that's a leg, and so I'm going to set this up as x squared plus 8 squared is equal to my hypotenuse, which is 13 squared. And if I simplify, I have x squared plus 64 is equal to 169. X squared is equal to 105 when I subtract that 64 from both sides. The square root of 105 is going to be 10.2. And so that is LO. So I solved for x right here, and that's 10.2. Okay, I'd like for you to go ahead and work number 2 on your own. Just pause the video, and then we'll get the answers to you. Okay, so I've got in-center, so I know that these are going to be this is going to be a right angle, this is a right angle, and this is a right angle. So those are the right triangles I'm going to be dealing with. We have to find GD. So if we look over here, I know that this is 35 and that's 37. So I'm going to solve for that missing leg there. So I've got x squared plus 35 squared is equal to 37 squared. And when you did the math on that, you should have ended up with x squared is equal to 144, and x is equal to 12. So GD is going to be 12. And now I know this is 12. Now that they gave us this distance from the in-center to the side, this is 12, and that means this also has to be 12, and this one right here is 12, because these are all equidistant from G. So then if I look over here, I see that I have another right triangle right here, where I have a 6 and I have a 12, and I'm going to solve for that hypotenuse, which is BG. So I've got 6 squared plus 12 squared is equal to x squared. That ends up being 180 is equal to x squared, so square root of both sides, should have put that on that one too. X is equal to 13.4. Okay, so we would say BG is 13.4, and that's the hypotenuse there, and I got that using this right triangle right here. Okay, and then for the last two, I need to find FC. So if I look at this, these are my angle bisectors, right? And so I've got two right triangles here, and I know that by hypotenuse leg, these legs are the same, they share the same hypotenuse, that these two need to be congruent. So that means FC is going to be 35. And then similar situation over here with BF. I've got, this is 12 and that's 12. They share that hypotenuse, and we have the right triangle, so BF is going to be 6, just like BE is 6. So I'll put 6 on that one. All right, let me hold it there just for a second. You can pause it if you need to. All right, number 3, if this is a little bit different, now we're actually focusing on the angles. If you've noticed, we haven't really done much with the angles on this one, even though we're using the angle bisectors. If S is the in-center of triangle PQR, S is our in-center, the measure of angle PRQ, so they're giving us PRQ, this whole angle measure, and we have an algebraic expression. And then we have RPQ, sorry, and that's that right there, and then we have PQR is this entire angle over here. So find each missing measure. Well, first of all, I need to figure out what X is. So I have the 3 angles in algebraic expression, so I want to just go ahead and add those all up and set them equal to 180. So I'll take 8x minus 10 plus 4x minus 14 plus 7x minus 5 is equal to 180. So you're going to end up with 19x is equal to 209, x is equal to 11. All right, so now that I know that x is 11, what I'm going to have to do is go back and plug 11 into 8x minus 10. So 8 times 11 minus 10, I get 78 degrees. So that means that this whole, the larger angle here, PRQ, is going to be 78. And then 78 degrees. And then I'm going to drop down to where they're asking for PRS. So here, if I know that this whole thing is 78 degrees, and this is an in-center, which means that these angles need to be congruent, these need to be congruent, and these are congruent. So if this is 78, then PRS is going to be half of 78, which is 39. So that would be over here, 39 degrees. Okay, and you're going to use the exact same process to figure out all of these whole angles and then take half to fill in over on the side. So go ahead and pause the video, do that work of plugging in, and then we'll check it. So there are the answers that you should have gotten. That's it for the in-centers, and so for the remainder of the block, how much ever time you have, I would like for everyone to be working on this. It's a class copy, and they're on the bookshelf. Go ahead on your own sheet of paper and, work the problems on your own. It's front and back. I'll have keys that you can check your work on. And then if you finish that, you can do a scavenger hunt, which is around the room, and use your own sheet of paper as well, and I have a key for that. So those will be your opportunities to practice. And then your homework for the evening is going to be homework number 3, and so you'll want to finish that, and everything should be on the bookshelf just like it usually is. All right, that's it. Thanks.